Okay, so first of all, let's remind ourselves about something you had previously. So we all know this. We all know that if we have 2/3 divided by, let's say, 4/5, okay? We know that when we're dividing, we always need to change this to a multiplication problem. So we change division to multiplication. So this becomes 2/3 times the reciprocal. So remember, to change a division to multiplication, you have to take the reciprocal of the fraction following the division symbol. So the reciprocal 4/5 is 5/4. And so now you do it just like we've been doing. So you're going to reduce. So 2 and 2 is 1, 2 and 4 is 2. And that's all I can do. And so the answer is going to be 1 times 5 is 5, 3 times 2 is 6. So that's the idea you're going to use with rational expressions. So the first thing you're going to do is change it to multiplication. So let's look at number 1. So in number 1, we have x minus 9 divided by x minus 3 times x plus 3 divided by, so this is division now, not multiplication, division, divided by x minus 9 divided by 5x squared times x plus 3. All right, so first thing you must show is changes to multiplication. So you must do that first. So the first step is to change division to multiplication. So you're going to rewrite the first rational expression as you see it, just like that. And then you can say times the reciprocal. So the reciprocal. So the denominator becomes the numerator becomes the denominator. So 5x squared times x plus 3 divided by x minus 9. And now you're going to do this just like you did the previous problems. You do it just like the rest. So the only new step is this. The only new step is changing a division to multiplication. And all you do is just take the reciprocal of the fraction following the division symbol. So notice though that everything is already factored. See, these are factors already. So there's nothing to factor. So let's just reduce our factors now. X minus 9 divides to x minus 9. My next factor is a 5. There's no factor 5 down here. The next factor is an x squared. There are no factors of x's in the denominator. The next factor is x plus 3. I have one right here. So those divide out, and you're done. You just write it as one fraction. So you go 1 times 5 times x squared times 1, which is 5x squared. And then x minus 3 times 1, which is x minus 3. There's your answer. So the only difference was changing division to multiplication, and then the rest is what we've been talking about. So let's look at number 2. Number 2. All right, so suppose we have 2x plus 6 divided by 5x plus 10, and that's being divided by x plus 2 divided by x squared plus 4x plus 3. All right, so again, the first step you have to do is change this division to multiplication. So you got to change this to multiplication problem. So rewrite this with a multiplication. So this becomes 2x plus 6 divided by 5x plus 10 times the reciprocal. So you get x squared plus 4x plus 3 in the numerator, and the denominator is x plus 2. And now the rest is what we've been doing. So we factor everything now. So the next step is to factor. So when I factor the numerator here, that's going to be 2 times x plus 3. The denominator, the GCF is 5, so it'll be 5 times x plus 2 times over here, I can factor this as x plus 3 times x plus 1, and then this denominator I cannot factor, so that stays x plus 2. All right, so I change this to multiplication by taking the reciprocal, and then I factor. And then the next step is to reduce. So my first factor sees a 2. A 2 will not go to anything in the denominator. The next factor C is x plus 3. There's no factors of x plus 3 in the denominator. The next factor is x plus 3. There's no factor of x plus 3 in the denominator. And then the next factor is x plus 1. There's no x plus 1 in the denominator. All right, so there's nothing to factor there. And so then you would just say, well, since there's nothing to factor, you would say, well, the answer is going to be as one fraction. You're going to say 2 times x plus 3 times x plus 3 times x plus 1 divided by 5 times x plus 2 times x plus 2. Now, you can also write this as this, just to let you know. You see how you have two factors of x plus 3? You can write this as x plus 3 squared times x plus 1. So that means the same thing as this. And over here, you can say 5 times x plus 2 squared. All right? Now, so that was number 2. Number 2, I couldn't reduce. So it is possible where you can do all of this and there's nothing to reduce. Okay? But you still have a final answer, though. Now, let's look at number 3. Number 3, what if I had this instead for number 3? What if I had this? All right, number 3, we have 2x plus 6. So almost the same problem, except this time, I'm going to write it like this. Okay, so I'm going to do this one instead. So it's almost the same as this one, except I'm going to reverse this. All right, so again, the first thing you do is change this to multiplication. So I get 2x plus 6 divided by 5x plus 10 times, and then the reciprocal will be x plus 2 divided by x squared plus 4x plus 3. All right, and then you reduce, then you factor. So that's 2 times x plus 3 divided by 5 times x plus 2 times x plus 2. And then you can factor this one as x plus 3 times x plus 1. And then notice here, I can reduce some factors here. See, these x plus 2's divide out. And then these x plus 3's divide out. And all you have left then is 2 times 1 times 1, which is 2. And then 5 times 1 times 1 times x plus 1, which is 5 times x plus 1. And so that'll be your answer there. All right, so if you cannot reduce, then you still have to put it as one fraction. You can leave it like this, or you can write it in more compact form. If you can reduce, you must reduce, and you must show how you're reducing. So you see, you cross them out, put ones in there as factors. And don't multiply it out. Leave it as 5 times x plus 1. Leave it as 5 times x plus 1. Don't say 5x plus 5, because you could, but if you made a mistake, you can be very upset because you could have left it as this. All right, let's look at number 4. Number 4, let's suppose we had this in number 4. We had 6 divided by x squared plus 9x plus 20. And that rational expression is being divided by this one. Let's say it's 6x minus 12 divided by 8x plus 40. All right, so again, the first thing, see division? The first thing you do is change the multiplication. So I have 6 divided by x squared plus 9x plus 20 times the reciprocal. So that's going to be 8x plus 40 divided by 6x minus 12. Now reduce. This is a monomial. There's nothing to do there, so I'm going to rewrite it. This I can factor as, let's see, that'll be x plus, it looks like 5 and 4. So x plus 5, x plus 4. Times, over here, in the numerator here, I can factor out an 8. So it'll be 8 times x plus 5. The denominator, I can factor out a 6. So that's 6 times x minus 2. All right, so let's talk about your factors. My factors are 6, 8, and x plus 5. In the denominators, my factors are x plus 5, x plus 4, 6, and x minus 2. So let's go ahead and reduce. There's a factor of 6 here. I can reduce this 6 with this 6 because those are the same. So those divide out and you're left with factors of 1. 6 divided by 6 is 1. I have an 8 here. 8 will not reduce with any factor in the denominator. I have an x plus 5 next. That will reduce with this one. And notice all you have left is this is your answer. 1 times 8 times 1 is 8. Over here you have 1 times this binomial times 1 times this binomial, so it's just these two binomials multiplied together. And don't multiply it out. Leave it in factored form, because if you do multiply it out and there's an error, you're not going to get full points, even though this was acceptable. All right, that was number 4. So let's continue on. Let's look at number 5. So number 5, we have, let's see, this is number 5. All right, number 5, let's say we had this in number 5. We had m squared minus 2m minus 8 divided by 8m plus 24. And that's being divided by this rational expression, which is 2m minus 8 divided by m squared plus 7m plus 12. All right, so first thing you're going to do is change this to multiplication problem. So we're going to rewrite everything, and we're going to multiply by the reciprocal of this. So we got m squared minus 2m minus 8 divided by 8m plus 24 times the reciprocal. So you got to show this part here. M squared plus 7m plus 12 divided by 2m minus 8. And then the next step is like we did in the previous lesson. You just you factor and then reduce. So the numerator here, I can factor that as m minus 4 times m plus 2. The denominator I can factor out an 8, so it'll be 8 times m plus 3. The numerator, I can factor that as m plus 4 times m plus 3. That's a 3. And the denominator, I can factor out a 2. So it'll be 2 times m minus 4. And then let's reduce. So I see a factor of m minus 4. There's one right here. So those divide out. I see an m plus 2, but there's none down here. There's no factor of m plus 2, so I cannot do anything with this one. The next one's m plus 4. There's none down there. The next one's m plus 3. There's one right here. So those divide out. And that's all I can reduce. Now, how do you write the answer? Well, you're going to write the answer like this. 1 times m plus 2 times m plus 4 times 1 is just these two multiplied together. M plus 2 times m plus 4. Leave it in factored form. Then over here, you have 8 times 1 times 2 times 1. We all know that 8 times 2 is 16, so you got to say 16. Don't say 8 times 2. You know 8 times 2 is 16. And there's your answer. That was number 5. Number 6, let's suppose we had this for number 6. Let's suppose we had 9x cubed plus 54x squared divided by x squared plus 5x minus 14. And that's being divided by 10x squared divided by x squared plus 5x minus 14. All right, so we have those two rational expressions that we're dividing. So again, you got to change this to multiplication. So this becomes 9x cubed plus 54x squared divided by x squared plus 5x minus 14 times the reciprocal. So x squared plus 5x minus 14 divided by 10x squared. And now the next step is to factor. Now notice over here, I can factor out, it looks like what, 9 times 6 is 54, so I can factor out a 9, and also I can factor out an x squared. So I get 9x squared times, the GCF is 9x squared, so I get 9x squared times x. 9x squared times x is 9x cubed, plus, and then 9x squared times 6 is 54x squared. So that is this. Divided by over here, I can factor that as x plus 7 times x minus 2. The numerator here, I can factor that as x plus 7 times x minus 2. So notice this and these are the same, right? So they should have the same factors. And in fact, since those are the same, by the way, since those are the same, you could have right away done this if you wanted to. Those are the same. This divides into this. Just like over here, watch. X plus 7, x plus 7, x minus 2, x minus 2. All right? Divided by 10x squared. Okay, so you could have done that at this point because those are exactly the same. This numerator is exactly the same as this denominator. So when you factor, you notice the factors divide out as well. But I want you to notice this. We're not done reducing because see this x squared here? That reduces with this one. So those divide out. And it looks like that's all you can do. So your answer is going to be 9 times x plus 6 times 1, so that's 9 times x plus 6, divided by 1 times 1 times 10 times 1 is 10. All right, so that's number 6. Now, let's look at number 7. Number 7. So in number 7, let's suppose we had this for number 7. Number 7. We have y squared minus 3y minus 54 divided by y squared minus 4y minus 45. And that's being divided by 2y squared plus 13y plus 6 and 2y squared plus 7y plus 3. All right. So again, the first thing you're going to do is change this to multiplication. So this becomes y squared minus 3y minus 54 divided by y squared minus 4y minus 45 times the reciprocal. You got to take the reciprocal. So the reciprocal is 2y squared plus 7y plus 3, and then 2y squared plus 13y plus 6. That's your first step. Then you're going to factor. So when I factor all these, let's see, this is going to be y minus 9, y plus 6. So that is this. This looks like it's going to be y minus 9, y plus 5. Okay, so that is this. Over here, I can factor that as 2. Let's see, that's going to be 2y plus, the 3 goes here, the 1 goes there. So it'll be 2y plus 1, y plus 3 is this. And then the denominator, that's going to be, let's see, 2y, y. This needs to be a 6, and this needs to be a 1. So it'll be plus, plus. All right. And then, so all these are correct, I think. Let's see. That's 12, 13. Yep, so that's right. Now let's reduce. So you see these reduce, right? So y minus 9 divide out. Y plus 6 and this y plus 6, those divide out. 2y plus 1 and this 2y plus 1, those divide out. See all that? And then this y plus 3, there's no y plus 3 down there, so I'm done. So now the answer is going to be 1 times 1 times 1 times y plus 3, which is y plus 3, divided by 1 times y plus 5 times 1 is y plus 5. And that's all you do. All right, I'm going to do one more with this one, and the one I'm going to do, and the reason I'm doing is because students get confused somewhat with this one. So watch. It's going to be 16x to the 4th divided by 3x squared divided by 8x to the 6th divided by 9x. All right, so just before we're going to first of all change this to multiplication problem. So I have 16x to the 4th divided by 3x squared times 9x divided by 8x to the 6th. All right. Now here's what throws students off. So notice these are all monomial factors. There are no binomials anywhere. They're all monomials. 16 times x to the 4th times 9 times x times 3. Well, 3 times x squared times 8 times x to the 6th. So what confuses them is there's these x's all over the place. That's what confuses students. Well, if that's the case, then what you may want to do is remember this. So I'm going to leave this as 16 times 9 for right now, just to kind of explain something. Because if you actually took your calculator out and wrote 16 times 9, it'll be a big number. But leave it like that. I'm going to show you what's going to happen. So 16 times 9. Now you remember when you had x to the 4th times x? You remember that property when you multiply like bases, you add exponents? So x to the 4th times x to the 1st is x to the 5th. So rewrite it like that. So rewrite this as x to the 4th times x is x to the 5th. And the denominator, leave it as 3 times 8, and then x squared, so you have x squared times x to the 6th, so x squared times x to the 6th. Again, when you multiply like bases, you add exponents, so that's x to the 8th. Because remember, it makes sense because I have 2 factors of x, 6 factors of x, altogether I have 8 of them. Now it's easier for them to reduce. So you see this 16? That reduces into this 8. 8 and 8 is 1, 8 and 16 is 2. You see this 3 and the 9? Those reduce. 3 and 3 is 1, 3 and 9 is 3. And then remember earlier we talked about this where you had, if you need to do it this way, do it this way. This right here means x times itself 5 times. Okay, 1, 2, 3, 4, 5. This right here means x times itself 8 times. 4, 5, 6, 7, 8. If you have to do like that, do like that, and then reduce. So all these common factors reduce out. Okay? And then look at what's left. The numerators, it's all factors of 1, so you get 1 in the numerator. The denominator is 1 times 1 times 1 times 1 times 1 times x times x times x is x cubed. So what that means is this. This becomes this 1 right here, and then this becomes x cubed. So x to the 5th goes into x to the 8th, x cubed times. And so the answer is 2 times 3 times 1 is 6. And the denominator, 1 times x cubed, is x cubed. All right, so students can do this other stuff here without difficulty, but when they get something like this, it does throw them off somewhat. All right, so that was division. So the only difference between this and multiplication is that the only step you have to do is change this to multiplication, and then the rest is what we've been talking about. All right, so that was division. Now,